Hello all. So in the 11th lecture we have seen about data types and variables, but I have not shown any example programs. So in this lecture we will see some example programs to show what is this data type and how to declare or define this variable and all. So we have already seen that lecture, we have seen this data types, what do you mean by this data type, and we have seen different types of data types. Mainly we have focused on this basic types. That is, we have seen char, int and all. So we'll see how to use this char data type. Then here I have specified this memory size as 1 byte and this range as -128 to 127. So everything was shown here, but I didn't show any example from this thing. So we'll see this example. So char. Now I'll take this terminal again. I'm going to take Vim editor, Vim, and I'm giving some file name. You can use any compiler. I'm using the name as data. You can give any file name. So I'm using data.c, vim.data.c. Now when you press enter key, this file will be open. So in order to type something, what you have to do is you have to press I. Then insert will come. Then you can type. So first thing you have to include is hash include, and within angle brackets you have to include stdio.h. So this is for the printf file, printf uh, printf function. Now hash include stdio.h. Then you have to have this int main function is there. Then the opening braces should be there. Then after that you can type anything. So there the previous we have simply used printf. Oh, so what you have done is printf, you have printed hello world. So what happens is whatever that is there in this, then it should end with semicolon. Whatever there is in the double quotes, it will be printed. After that, you have this return 0 and you have this closing braces. Now I am going to use this command. So char, how to use this char data type and how to declare a char data type variable. So I'm going to include another statement here. Now I have already mentioned that you can include this char. If you want to declare a variable as char, you have to use the keyword char space, and I'm giving a name to that variable. I'm giving a name chr. I'll simply use ch itself. Then it should end with a semicolon. So I have showed in the slide, if you see the slide, how to declare I have shown here. So rules, I have shown this rules also, and this char int, all this can be declared using this keywords. And how to define this, there should be type variable name. It should be like this int number, int j, like char c comma ch, like this you can declare. So I have declared a character ch is of character type. I have declared that thing. Now I am going to initialize some value to that. I want to give some value ch. So you have this equal, this is known as assignment operator. We will see what is an assignment operator in later lectures. So now you can include assignment operator, and within single quotes you can give any character. So only one character you can give, and this character will be assigned to this value. So this is actually char ch, it is actually a declaration. Ch is a character type variable declaration, and in C this can be considered as definition also, because when the compiler compiles, what happens is that this 1 byte of memory will be allocated to this ch variable. Now after that what happens is we are storing a character in that 1 byte of memory. So ch in ch you can use this. Now if I want to print that character, you can use this printf statement, and I'll include something character is, you can write, sorry. So you can include anything here. I am going to type character is, I am going to include a semicolon. I'll delete this hello world. Now I want to print this thing. So I have to print ch. So in ch what you have is the character a. So if I want to print that A, so I have to print that CH. So comma CH. I have included character is colon. So this, whatever the double quotes, it will be printed, and CH, this is a character that is to be printed. And additionally, in printf statement, we call it as formatted output. So we have to specify what type of ch is, what type of variable the ch is. So inside that printf statement, you have to mention that it is a character type variable that is to be printed. For that, you have to include a format specifier, and in order to specify that format, you have to include this percentage %c. So this tells the compiler that I have to print ch, and ch is a character type. So percentage %c is a format specifier. For percentage cs is a format specifier. So you can include any space in between, or after that you can include any space at all. So printf, what it does is, whatever inside this double quotes, it will be printed. And when it sees this percentage C, so when it sees this percentage C, what it does is, it knows that it should be replaced with the value of CH. So whenever the compiler sees this percentage C, what it does is, it will that percentage C will be replaced with the value of CH. So what is the value of CH? A is the value. So A will be printed. So I'm going to save it. In order to save this thing, you have to press escape button, then colon W to save and quit. Now you can list this file. You can see that data.c file is there. Now in order to compile that, gcc data.c. Now there is an error here. I have forgotten to include a semicolon. So every statement should should end with a semicolon. So I'll again go back to the file. Now here I have missed a semicolon here. So what I have to include? I have to include a semicolon here. So I have to include an insert. I have to insert a semicolon here. So every statement should include a semicolon. So escape and colon WQ. Now you can again use this gcc.data.c, and there is no error. Okay. Now there is no error. So it has compiled. So I have compiled this gcc.data.c. There is no error at all. Now if you see that, in order to run that, ./a.out, when you print this character is colon, and instead of percentage C, A will be printed. So A will be printed. I'll again take that file. So I'll include a new line character also. So in order to insert that, I have to include a new line after this percentage C, to print it in a new line. To go to the next line, I'll use a /n character also. So escape WQ, colon WQ. Now I will again have to compile this. You cannot run this. So you have to again compile this, and again you have to run this. When you run this, the statement will be. So what happens is, inside this printf, whatever it is there. So what is there? Well, printf character is colon, and after that we have made a double percentage C is there. So that percentage C will be replaced with the value of ch. So value of ch. I will take that program. So the program is data.c. So it will open in code blocks, I think. So this will be opened here. So that character. So what happens is, I have all what inside this printf, the character is, the statement is there, and this percentage C will be replaced with the value in ch. The value in ch is A. So that will be replaced here. So this way you can run this program. Okay. So that is data type for character. Now you can include, it is not necessary that you should include this in two statements. I have already mentioned that you can simply remove this thing. So I will remove this statement, sorry, function. So I'll remove this thing, having removed this, and I am going to give the name, I am giving the value in the declaration statement itself. So I'll, within double quotes, I'll print as some other character R. Okay, character ch equal to R. Now I'll save the same thing and w colon wq, save and exit. Again I have to compile this, and again I have to run using dot slash a dot out. Now the character is R will be printed. Okay, so again I will go to this program, I'll edit this, and we'll see what happens if I am going to include one more character. So within quotes, I'm going to include another A also here. So we will see what happens. I'm going to save it, WQ. Now I have to compile it. So there's a warning will be there because multi-character. So within, when you are declaring a character, you cannot include multiple characters. Only a single character can be included in a double quotes. So there is an error in that program. So you have to go again. So I'll include, now I'll remove this. Okay, I'll remove this thing, and I'm trying to include a space here. I'm going to include a space, after R there is a space. Now I am going to again use the thing. I'll again compile this. Let me clear this first. Okay, I'll clear it first. So I'm going again to compile this. Again there is a warning because there is multi-character. So this space also cannot be included within the single quotes. So you cannot include a space also. So there is an error here. Okay. So inside, when you are declaring, you can include only a single character. You cannot include any other characters. Only a single character should be there. You can include any of the characters inside this single quotes. So what it does is here, or how this program executes is this R value. There will be an ASCII value. You will learn about ASCII value later. So that value of that R will be stored in CH. So here the CH is a character type variable. So CH is a variable, and it will be allocated 1 byte of memory. So we have already seen in the slide that 1 byte of memory will be allocated when it is a character type variable. So if you see this thing, so I have shown here. So 1 byte of memory, and the range will be from this. So this is the ASCII value. So 1 byte of memory will be allocated for this, and in that 1 byte of memory, this R will be stored. That is, in 8 bits, that R in the binary, some ASCII format will be there, some code will be there, and it will be stored in that memory location. When you execute this printf statement, what happens is, up to this colon and the space will be printed. After that, there is a percentage C. That percentage C will be replaced with the value in CH. The value in CH is R. So R will be replaced, and there is a slash. It will be a new line will be gone. So in this way, you can print a character. Now we will see another program. We will see how to uh, remove. Okay, I'll remove this thing. Okay, sorry. I'll remove this thing. I am going to print another integer. I am going to declare an integer variable, integer number. I will give the name as number, and I have to end with the semicolon. Okay, now I am going to give some value for that number equal to some value. I am assigning some value. So what happens is, I am declaring or defining this number as integer type. So since in this machine, in this compiler, for 2 bytes of memory, sorry, 4 bytes will be allocated. We are already, I'll show the size and all. So in certain compiler it will be 2 bytes, and certain will be 4 bytes. Let it be anything. So Here number equal to 10 is given. So what happens is some 2 bytes of memory or 4 bytes of memory will be allocated for that number in memory. Then in that 2 bytes or 4 bytes, this 10 value will be stored. Now I'm going to print this thing. So in order to print, I'll change this as, you can, sorry, I'll change it to something integer number. I'm going to print integer number is some space. Then what you have to do is there should be a formatting, and here let it be, I'll change it to numbers. Instead of ch, you have to print number. So I'm going to change it as number. Sorry, function. So I am going to print as. Now we have to include a formatting character also. So in character it is percentage %C, and for integer the formatting character is percentage %D. So percentage %D should be there. So I am going to print whatever it is, the double quotes. So double quotes integer number is colon, and the space will be printed. After that is percentage %D. It is a format specifier. So we'll see this format specifier and later when you learn about printf statement in detail. So percentage %D is a format specifier to print integer number. So instead of character, in character it is percentage %C, here it is percentage %D. So this percentage %D will be replaced with the value in this number. Value number is D. So we will run this program. So we will save this colon WQ. Now we will run gcc.data.c. We will compile this. Now we will run this ./a.out. When you run this, that will be printed. Integer number is colon, and instead of percentage %D, it will be replaced with the value in number. That is 10. Okay. Now I have mentioned that integer number. So if you see this thing in the slide, I have mentioned that if it is 2 bytes, the range is from this to this thing. So you cannot store a number greater than 32,767 and a number less than minus 32,768 if it is 2 bytes. But in this compiler, it is actually 4 bytes. So 4 bytes will be allocated. So I'm going to store a very huge number. I'm trying to store a very huge. Instead of 10, I'm going to store a very large number, like for a very, very big number. So I'm trying to store a very huge number, and I'm going to save it. Now we will see if I could save this thing, if I could compile this program. So I'm going to compile. So there is a warning. So integer literal is too large to be represented in that type. So you cannot use integer for a large number because only 4 bytes of memory is allocated, and 4 bytes the range is from some value is there. So it is beyond that range. So it is beyond that range. So you cannot use this. So you can need to use some other number like unsigned long in order to use that large number. So I'll replace this. So I'll replace with, so if you check this program, so here inside, then there is shortened, and we have a long int which can show 4 bytes. So here it is the which has a range of from this to this. So if it is 4 bytes, it can store up to this. So in order to store a large number, what you have to do is you have to make it long int, long int, and long int has also some value. So I'll reduce this thing. So this is now a large number which is greater than long int. I think around 8 bytes or 6 bytes will be allocated for this thing. Now what you have to do is you have to save this thing. Now you can compile this thing GCC, and you have to one. Now here this format specifier I have to change. I have to include percentage %D here. So that is a part of the format specifier for long number. So it has given a warning. You should use percentage %LD here. So we'll learn about this format specify later, but I just wanted to show how to print, how to declare some values, sorry, some variables. So instead of percentage d, percentage ld should be specified. So this means it is a long int. It is, so I have declared it as a long int. So the number is a long int. So in order to print that thing, you have to include that. So you can again compile this gcc data.c. Now there is no warning or error. Now you can come run this program dot slash a dot out. So that value will be printed here. Integer number is that value will be printed. So in order to include, so in order to print a large number, you have to use long int. So the same number, if you try to make it int, so we'll check what happens if we try to print it as an int. Maybe the range is above 4 bytes. Let me check. Escape WQ. Let me clear this. Now again I will compile GCC data. So there is a warning here. Sorry. I have to remove that. I'll remove that percentage LD also. So since it is integer, I have to make it uh, percentage d itself. Now escape colon wq. Now I will again compile this. So there is a problem here because long should be used. It automatically says what should be done. Instead of int, you have to use long int. Then only you can, because the range is up to 27644723 for int. So if there is a value above, so here it is 4 bytes. That's why it is the range, it is given like this. So in slide I have mentioned different. If it is a 32-bit OS, it is 2 bytes. Here it is 64-bit OS, and the compiler gives this much memory. 4 bytes is allocated for int, and the range is up to 276644732. So this number is larger than this number. So you cannot store here this number, only up to this range. That is why I have mentioned about this range of values. So if it is long int, this is the last range of value you can store. So if you want to include a larger byte, you have to make it long int. So this is for 32-bit. So that is why the range for long int is like this. But in this my system, for the int itself, this range is like this. Okay. So you can change it. Okay. So let it be number. Now I'll show some other thing. So after that, int, long int, short int, and all, there is another thing for floating point numbers. If you want to have fractional numbers, you have to use either float or double or long double. So this storage size will be different in my system. So this is for 32-bit OS. So I have mentioned here 32-bit OS. So it will be 4 byte, 8 byte, and 10 byte. This compiler it will be different. I'll show the size later. So now will see some example program. I'll use the same program and I'll declare another variable. I'll declare another variable float. I'll use the same variable name float number, and I'm going to declare, I'll delete this thing. So I'll be using a fractional number for 10.245. So I'm going to store this number, and here this is float number. So again, what you have to do, you have to change the format specifier here. The other things are same. You have to change the format specifier. Since it is float, you have to use percentage f. Since it is float, so integer, it is percentage d. For character, percentage c. For long int, it is percentage ld. And for float number, it is percentage f should be there. Now escape colon wq. Now I'll clear it. Okay. Now again I'll compile this. There is no error. Now I have to run this dot slash a dot out. Sorry, here I have given as integer number, whatever you can type, you can. So integer number is point. If you want, you can change that also. That value will be printed. Okay. So you can change this also. If you want, you can change this instead of integer, you can use float. Sorry. So I'll change it to float. Float number is okay. So I'll compile it now, run it. So float number is that 10.245. So three more zeros have been added. I have just given 245. So this much precision is there. That's why 10.245 zero is displayed here. Now, if I want to include a very large number also, uh, you can include. So we have seen this float type. Then there is another type that is double. It is also up to 15 decimal places. Here it is 6 decimal places. If it is 4 bytes, it is 15 decimal places. So we will see. Then we have double and also we have already seen this. So double, long double is there if we want huge numbers. So we usually will use char, int, then long int sometimes, and also we'll go for float. So we will see about this formatting character and all later in later lectures. So next we will see, we have already seen how to declare variables and all. So if you see the slide, we have seen the rules for declaring variables. What is this variable? So we have seen how to, then we have already seen this variable rules also. So how to declare this variable and also this variable rules in the 11th lecture. So you can refer that 11th lecture. So we will check those rules also. Now we will take the same program. I'll change it. So I'll change this thing. I'll let it be int itself. Sorry. I'll make it int itself. Uh, so let me check. I'll use the int itself, int number. Now I'll change it to number here. Also I'll change it here. Some 105. Then I'll change here also number is percentage d is to be here given here, percentage d number. So now the program is correct. Now I have mentioned that we can declare variables here. So if the variable is a type of identifier, so it should start with a digit or you can start with an underscore also. So this is will be also be fine. So this will be also be fine. Now I'll use another variable name. I'll declare some other thing char. I'll give another name. I'll give float. I'm sorry. I'll give some other auto. I'm going to use an variable name auto. So you'll check what happens. Now I'm going to declare another float type of. I'll start with 2, 3, ABC, and I'll give another integer. You can give any name. So I'll give number 1, 2, 3. So we will check what happens here when we compile this program. So I have simply declared int underscore number is there, then char auto, then float 23 ABC, then int number 123 is given here. You can give any value. So I just want to see the difference between what all errors that can occur in this program. So I'll again compile this. Now we'll see the errors that have occurred here. So first error here it is char auto. It is not. This cannot be used because auto is a keyword. So that is a problem here. Let me check. There is some error. There is some error. Let me check. WQ. Sorry. If I have missed any, no, there is no error. There is this line is compiled correctly. There is no error in this because underscore we can start a variable name with underscore. But this line there is error because we cannot use the word auto here because auto is a keyword. So instead of auto, I am using auto one. Okay, I'll use auto one. Insert auto one. Okay, now again I'll run this program. GCC data.c. Now there are three errors that are generated. Now there is some error here. Expected identifier this parenthesis because there is error in this line 2 3 float 2 3. So this cannot be done because no variable can start with a digit. It should be either underscore or it should begin with an alphabet. So there is an error here, that is why it cannot be like this. So again I'll change that error here. So I'll start with A123BC. Okay, now again I'll save it, again I'll compile it. Now again there is another error. Number. So there is an error, undeclared identifier number, because I have not declared number, I have declared only underscore number. So underscore number and number is different. So again I have to edit this thing. So there is an error here because this should be underscore number. Again there will be error here also because it is again underscore number. Now let me give a capital letter here. Instead of I'll give an N as capital here. Okay. Now again I'll save it and compile it again. Now again there is an error. End underscore number declared here. So it is declared here. It is declared. So and the usage, so there is a problem here because I have used a underscore capital N number, but actually it was underscore small number. I have already mentioned that C is a case sensitive language, so slash underscore number and underscore capital number is different because N is capital here and N is small here, so both are different. So I have to again change it. So either I have to make it capital here or you have to make it small here. So I'll make it small here. I'll make it small here. Okay, I have to again save it and quit. Now I'll again compile it. Now there is no error. Now if you check this, when you compile this, there is no error. Now if you run this dot slash a dot out. Now number is 105 will be printed. Even though I have declared many variables in this program, I have not used all those programs. You can simply print all this. You can give some values and you can print. I just wanted to show the different type of variables that can be used. So underscore, we can start with underscore. We can start with digits also. You cannot use auto, but auto one is permissible. Auto is a keyword. So it is a reserved word. You cannot use it. And I have also shown the difference between a small n and capital N. So this thing, so that's all about data types and variable declarations. Thank you.